Good morning. In today's session, we are supposed to study about why we are using the digital communication. In previous session, we have studied about the block diagram of digital communication system. We have seen we are doing the communication that will be the digital. So communication is nothing but it is occurring in our day-to-day life. It will be in the form of signal. This signal such you can take as a sound signal. Generally, these are analog in nature. When we are supposed to do communication, it will need to be established over a distance. It means what? If you are doing the communications, sometime you guys will be sitting in front of each other. Sometime your friend will be at other place. There will be some distance, but you can communicate with that person. It means what? We are making the communication over a distance. Then we are transferring the data. That data is nothing but the analog signal. We are using the different technique to do our transmission effective. But here we are supposed to study about digital communication. So what is the necessity of the digitization? It means what? If we are doing the communications that is used analog signal for a long distance, it will suffer from many losses like distortion, interference, other losses, which will including the security. So in order to overcome these problems, we are supposed to make that signal digitized using the different technique. So we will minimize the distortion, interference, that loss, and we will get the communication easily, and the transmission will become effectively. So the digitized signal allows the communication to be more clear and accurate without the losses. So here we can see there are lots of advantages digital communication have over analog communications. So we are using the signal. What does mean by signal? Signal is nothing but a electromagnetic or electrical current that carries a data from one system to another system. It means what? When we are doing the communication, we are doing the communication using the signal. It means what? A signal is nothing but it is a time varying voltage that is also an electromagnetic wave carrying information. Through it can take in other forms such as current. There are two types of signal, that can be analog or that can be a digital. So analog signal is nothing but the signal which is time varying and generally bound a range. It means what? It will have a range. Like you can take any example. Like it will have the range from minus 12 volt to 50 plus 12 volt. But there is an infinite number of values within the continuous range. It can take any value from that the range. Analog signal uses the property of medium to convey the signal, that will be the information. It means what? It can convey that signal through a wire. It means we can transfer electrical current, electrical voltage using the wire. But when we are supposed to study about the digital signal, what will be the digital signal? Digital signal will be the signal which will represent the data as a sequence of the discrete values. It means what? Digital signal only takes one value from the finite set of possible. With digital signal, the physical quantity representing the information, that can be many things. You can take variable electric current or voltage, the magnetization of magnetic storage medium. So digital signal we are using in the digital electronics, including the computing equipment. We can use digital signal in the digital data transmission. So here we are supposed to study why we will require digital communication, because it is easy to regenerate the distorted signal, because when we are digitizing the signal at that time, it will minimize the distortion, the losses and the interference. So there is easy method to regenerate the distorted signal. Regenerative repeaters along the transmission path can detect a digital signal and again it can retransmit that new, clean, without noise free. It can transfer that signal. These repeaters prevent the accumulation of noise along the path. It means what? It will reduces that noise. And this is not possible with the analog communication system. Just because of this reason, we are supposed to study about the digital communication. So the input in the digital system is in the form of sequence that will be, you can say, as a binary or a array. So it is higher immunity to distortion and the interference. Here noise immunity is higher as compared to the analog communication. Again, if you see, digital communication is rugged in the sense that it is more immune to the channel noise and the distortion. If you see, all the things will tell us like digital transmission is reducing interference, the noise, and it will have higher noise immunity. It will reduces the distortion. So here if you see, the hardware is more flexible as compared to the analog communication. If you see about the hardware, its implementation is flexible and it permits the use of different types of electronic devices like microprocessor, mini processor, digital switching, VLSI. So our hardware will become flexible. Its cost will be less as compared to the analog communication. Its design is shorter and the production cycle. The use of large-scale integration and the very large-scale integration in the design of components and the system will result in low cost. So you will get the cost that will be lower as compared to the analog communication. It is more efficient, easier to multiplex several digital signals. We can do here multiple access technique like you can use TDMA, CDMA, FDMA. These are easier to implement that analog technique such as frequency division multiple access. If you see, we can use digital communication because it is having lots of advantages like it can combine different signal type, data, voice, text. Digital communication is nothing but it is digital in nature, where voice communication will be in analog in nature. So here we can use the digital communication. The two types of communication are difficult to combine over the same medium in the analog, but it will be easier. It is possible to combine both formats for the transmission through the common medium by using the digital technique. So we can use digital communication. If you see, again it is having lots of advantages like it gives better performance as compared to the analog communication. If you see, digital communication is inherently more efficient and it will give us the exchange of signal to noise ratio for the bandwidth. We can code digital signal to yield extremely low rates and high fidelity, as well as we will get here privacy. So here we can use the digital communication because if we are doing the communication by using the analog information at that time, there will be higher amount of noise. So we are supposed to make our communication noise error free. At that time we can use digital transmission because it is having high noise immunity. It is having reduced distortion interference. So here if you see, digital transmission is having some disadvantages also. We are using the digital communication instead of analog communications because if you see, in analog communication we are having lots of disadvantages like it will require reliable synchronization. It will require analog to digital conversion at a high rate. It will require larger bandwidth. There is performance criteria and the probability of error or the bit error rate. So here we are supposed to study about the digital communication. Why we will require? Because we are overcoming the problems like distortion, interference, lots of losses by using the digitization, by doing the digital communication, because digital communication are having lots of advantages like the effect of distortion, the noise, interference in much less in digital signal are less affected. Digital systems are more reliable. These are easy to design. These are cheaper. It means what? Its cost is less as compared to the analog. The hardware implementation in digital circuit is more flexible than the analog circuit. If you see, we can use here different type of multiplexing technique. Combining digital signal using TDMA is easier than combining analog signal using the FDMA, frequency division multiple. So here we can use digital communication because its hardware is very flexible. The occurrence of crosstalk is very rare in the digital communications. The probability of error occurrence is also reduced here. So we can use the digital communication. So here we are supposed to study about calls in communication system. What we are supposed to do here, when we are supposed to use digital communication, at that time we are supposed to maximize its transmission rate. We can denote by letter R. You can see in the diagram here. I have shown R in the upward direction. It means what? We are supposed to maximize that. We are supposed to maximize the utilization. So we can use the digital communication. We are supposed to minimize the bit error rate. It means what? Here we are supposed to minimize the error. We are supposed to minimize the system bandwidth. We can denote by letter W. You can see we have drawn in the diagram and giving the downward direction arrow. It means what? We are supposed to minimize this value. We are supposed to minimize the complexity, Cx. We are supposed to minimize the required power, Ep by N0. It means what? Here when we are supposed to use the digital communication, at that time we are supposed to maximize Ru. We are supposed to minimize Pe. This is bit error rate. We are supposed to minimize system bandwidth. We are supposed to minimize complexity, and we are supposed to minimize the power. So here now we are supposed to study about the digital signal nomenclature. It means what? Here when we are using the information, that will be discrete output. It means what? You can take any example like a keyboard. If we are having the analog signal source, like if you are having the analog signal, you can take example as a output of microphone. It means what? Here your input will be analog signal, but at the output you will require the discrete output. That will be the digital. It means what? When we are taking the alphabet from the A to Z, or you are taking the number, that will be from 0 to 9, the decimal numbers. At that time, characters can be mapped into a sequence of the binary digits. Binary means only in 0 and 1. By using the standard code, such as you can use ASCII code, this is nothing but American Standard Code for the Information Interchange. You can use EBCDIC. It is nothing but the Extended Binary Coded Decimal Interchange Code. It means when we are supposed to use digital transmission, at that time you will require the output data that will be in the digital form. So you can use the character like from A to Z and the number from 0 to 9 by using the ASCII code, or you can use EBCDIC code. So here we will have the digital message. It means what? We can construct the message from finite number of symbol. Example, we can print any language that is consist of the 26 letter, the 10 numbers. 10 means 0 to 9 and 26 capital A to capital Z, the letters, alphabets, space and several punctuation marks. Hence, a text is a digital message constructed from about 50 symbols. Here we are using 26 letter, 10 numbers, some punctuation marks. So here we will get the message that will be constructed by using the about 50 symbols. So here Morse coded telegraph message is a digital message which we can construct from two symbols. These are nothing but mark and space. So here we are having the message MRE. So a digital message we can construct with the M symbols. And here when we will transfer the data and at the output, when we will get the digital data, at that time we can draw the digital waveform that will be for the voltage or a current waveform which will represent the digital symbol. Again we can calculate the baud rate. Baud rate is nothing but the rate at which we are transferring the data. So here we can calculate the actual rate at which we are transmitting the information per second. So it will give us the rate at which we are transferring the communication. So here again we can calculate the baud rate also. So what does mean by baud rate? It is the rate at which signal elements are transmitted. So here we can calculate the baud rate, that is nothing but the number of signaling element per second. Again we can calculate here the bit error rate. It means what? Here we can calculate the probability that one of bit is in error or simply the probability of error. So here we are supposed to study about the digital pulse modulation technique. This is nothing but it is the process of sampling where we are supposed to see about the two types. These are nothing but the pulse code modulation and the delta modulations.